Hey, let's finish up on homework for 7.2b. This is on washer method. Let's look at 15. We have the shaded region created by these boundaries here. So y equals x, this is a diagonal line, positive slope. Y equals 3, horizontal line. X equals 0, this is the y-axis. And we shade this region here. We're going to create a triangle shape. Okay. Now we're going to revolve this shaded region about the line y equals 4. So here's y equals 4. Okay. So this is the center of our of this object that we're going to be creating. And if we're revolving this shaded region about this this axis, okay, and we have determined, are we going to be using this method or washer method? And you see that there's a gap between the axis and the shaded region, so we know we have to go through washer method. We have to identify big R and little r. So starting on the axis, we're going to draw radius big R to the further curve line or graph. In this case, this is going to extend all the way down to y equals x. Okay, so that's going to be our big R. Little r, we start on the axis, and we're going to draw to the closer curve, or a closer line, in this case, the line y equals 3. So we have to do everything in terms of top minus bottom because we see vertical radius. So now we identify the top of the big radius, which is at 4. We look at the bottom of the radius, and we see this is at x, so we get 4 minus x. And little r, we look at the top of the little radius, which is at 4. The bottom of the radius is at 3, so 4 minus 3 is equal to 1. And we are ready to plug this in our formula. One thing is we have to determine where this where the bounds are. So we see that we're looking for our bounds in terms of x values. So here you see the x value is at 0. And here we see the y value is at 3. So to find the x value, we have to set these equations equal to each other. So set x equal to 3. In this case, that's going to be the same number, so x value is 3. Okay? But just keep in mind that this 3 is not referring to the y value. Okay? This 3 is coming from the fact that we're setting these equations equal to each other, and it is the x value of 3. It just so happens that because it's y equals x, every ordered pair in the first quadrant is going to have the same x and y value. Okay? But just keep in mind, you're looking at the x value here, not the y value. Okay? Many times you have to find this yourself if you can't pick it out from looking at the graph. Okay? So big R squared minus little r squared. Okay? Expand or go through power rule, plug in your calculator, you get 18 pi cubic units. Okay, number 17, we have our shaded region that is created by these 3 graphs, or 4 graphs. We have y equals 1 over x plus 1, that's this curve here. We have y equals 0, that's the x-axis. We have x equals 0, that's the vertical line, the y-axis. And then we have x equals 3, another vertical line here. So all these 4 graphs and lines have to contribute as boundaries for your shaded region. So here's our shaded region that's created. Okay. We're going to be, the axis of revolution is about y equals 4. So here's y equals 4. Okay. Next thing, we have to look at the axis in relation to the shaded region. Notice that there's a gap. So we have to go through washer method. Start on the axis, we're going to draw to the further graph. In this case, this will extend all the way down to y equals 0. Start on the axis, we're going to draw to the inner graph, the closer graph. In this case, this will stop at 1 over 1 plus x. So now we're ready to find big R and little r. So big radius will be the longer length, So start at the top. The top is at 4, so we write down 4. Minus, now look at the bottom, which is at 0, so 4 minus 0. Okay, little r, we're going to start at the top here, which is 4. Look at the bottom of the radius is hitting this graph 1 over 1 plus x, so that's little r. And then our bounds is in terms of x. So we look at the furthest x value is 0, the furthest right x value is 3. So we can simply look at the graph and figure out the bounds being 0 and 3. And then we're ready to plug in. So washer method is big R squared minus little r quantity squared. And all this can go in your calculator. You're going to get 10.340. Don't forget the pi cubic units. Okay, 21. We have the equation x equals y squared. That is a parabola that opens to the right. We have the vertical line x equals 4. And those are the only boundaries that's given to us. So if you see that we have basically a parabola that opens sideways with it being cut off. Notice that this does not say anything about the x-axis. So the x-axis is not considered the boundary. It just so happens that it crossed the x-axis. But if it doesn't include it as a boundary, then we're going to make sure that we don't cut it off because this is not a boundary. So it's going to be this entire shaded region that we're going to be starting off with. Revolving about the vertical line x equals 6. So here's x equals 6. Compare the shaded region to the line, the axis, and we see that there's a hole. So we have to go through big radius and little radius. So start on the axis. This is the center of your object, of your solid. So we're going to take start on the axis. We're going to draw to the further curve. In this case, this will be the y squared. Then we have our big R. Start on the axis. We're going to draw to the inner curve, the closer line or graph. In this case, the x equals 4. And then we're ready to create our big R and little r. So big radius, right endpoint is at 6. The left endpoint is at y squared. So right minus left, 6 minus y squared. Okay. Little r, we look at the right endpoint. The right endpoint is at 6. The left endpoint is at 4. 6 minus 4 is equal to 2, right minus left. Okay. Next thing we need to do is we need to find intersections. So we have to identify the lowest y value and the highest y value. So to do that, we need to find these 2 points. Okay. And if I can set this equation, x equals y squared, equal to this equation, x equals 4, then basically I can set y squared equal to 4. If I do that, then I can locate these 2 points, which we'll be able to use for our bounds. So set y squared equal to 4, y is equal to plus or minus 2. Do a visual check, and that makes sense, right? We have a positive and negative value, symmetrical, about the x-axis. So then we're ready to plug into our volume formula. So volume is pi big R squared minus little r squared. We simply look at what we found from big radius and little radius and start plugging into our formula. Lower bound being -2, upper bound being +2. So we get 384 over 5 pi cubic units. Okay. 46, we're given 3 volumes, and we have to determine which one will create the largest volume, which one's the middle, and which one's the smallest. So first we have a shaded region that is revolving about the x-axis. There's no gap. This is just going to be using the disk method. But if you look at part B, we have the shaded region revolving this about the x-axis. And then part C, we have shaded region and revolving this about shaded region here and revolving about the line x equals 8. And we see that part B, this is actually going to create the region with the largest volume. And the reason why is because we're revolving this portion the furthest distance away from the axis. So if you compare this with part C, you see that we are rotating something that is small versus something here that is much larger across a much larger distance. So this was going to create the largest volume. Okay, and this is going to create a larger volume than part A, simply because it's going across a larger distance. So B will be the largest volume, followed by C, and the smallest volume will be A.